Hi all, good evening. Today we will see what is nozzle diffuser and we'll also see about steady flow energy equation. So just see the picture. So before that we will see what is the law of conservation of mass. For example, in a flow, in a pipe or nozzle or diffuser, whether it is a liquid or gas, the mass flow doesn't change. That means whatever comes inside that has to go outside. So rho AV should be constant. Rho 1 A1 V1 at inlet should be equal to rho 2 A2 V2. So that is what called as a law of conservation of mass. Okay, because for liquids there is no density change, so we can cancel the rho from the both the things, both the sides, and we can write A1 V1 equal to A2 V2. Okay, now this pipe, we see that pipe. So this pipe, there is a flow of water splashing outside from the pipe. When you put your finger and reduce some area, so there is a splash of water. So why there is a splash? Because the velocity is increasing. Why the velocity is increasing? Because flow is constant. Whatever is coming inside the pipe till this now, till this, it has to go outside. So when you reduce the area, cross-sectional area, there is an increase in velocity because the flow rate has to remain same. So that's why the velocity is increasing to keep the flow constant. Now we will go to steady flow energy equation. In a flow, if you take inlet and outlet or at any point in between, so what happens is enthalpy plus kinetic energy plus potential energy plus heat transfer should be equal to outlet, plus here we have taken a work done. So this is called steady flow energy equation. Okay, when you apply the steady flow energy equation for nozzle or diffuser, what we are doing is there is no heat transfer because this nozzle, assume that the nozzle is completely isolated from the environment, there is no heat transfer or work done, so both the terms become zero. And there is no inclination, it is flat, so there is no difference in the potential energy, so we can remove that also. So for nozzle or diffuser, it comes h1 v1 square divided by 2 equal to h2 plus v2 square. So you here when you solve it, you get v2 is equal to square root of 2 into h1 minus h2. This is one important formula which we can use to resolve the problems. So one more thing here we have to note, what happens in the nozzle is when the flow is entering, because of the reduced cross section area, as we have seen in the pipe, the velocity has to increase. So in the nozzle, what happens, pressure is reducing and velocity is increasing in the nozzle. Then there is a straight portion. After that you have a diffuser. In diffuser the opposite thing happens. So pressure increases in a diffuser and velocity reduces, whereas in a nozzle your velocity increases, pressure reduces. So but one thing here we have to note, so in thermodynamics book we are studying about here this one, we are taking an example of a liquid. So suppose you it is applicable for gases, then it is Mach number below 1, this rule is applicable, but when the Mach number goes above 1, then this region acts like a diffuser and this region acts like a nozzle. So that you remember that when we go for the gas dynamics, we can look into that. Thank you.